Welcome to the Deep Dive. Today we're plunging into the world of Antarctosaurus, that southern lizard from South America's Late Cretaceous.
Right.
We've got a stack of papers here, and we're really going to try and, figure out what we actually know about this Titanosaur.
Yeah, it's a bit of a puzzle.
We'll look at the classification challenges, what the bones tell us, the different species, all that stuff.
Exactly. And we have to start with Friedrich von Huen's work back in 1929. That's the foundation.
But later research has kind of complicated things sometimes.
Oh, definitely. Built on it, challenged it, and the range of fossils attributed to Antarctosaurus is pretty wide. Tiny skull bits, massive leg bones.
And that's part of the hook, isn't it? The mystery. Like,
Yeah.
are all the bones found for the main species, Antarctosaurus wichmannianus, even from the same animal?
That's a huge question.
Plus, some of these things might have been absolutely enormous. We'll get into those staggering size estimates.
For sure.
Okay, so Antarctosaurus, southern lizard. First thought, Antarctica.
It's a common thought. But no, it's Argentina, southern continent. You know?
Okay.
The name just means southern lizard because Argentina's in the southern hemisphere.
Right.
Not related to the icy continent itself, despite the similar roots.
Gotcha. So, Antarctosaurus wichmannianus, that's the type species, the main one we need to sort of get a handle on. Where does its story start?
Well, the fossils were first mentioned in print way back in 1916, actually.
Oh, earlier than 29.
Yeah, but it was Huyen's big 1929 paper that really described and officially named it.
And he named it wichmannianus after.
Ricardo Wichmann. He was
Right.
the geologist who actually found the bones back in 1912.
Okay, 1912. And where did Wichmann find them? What part of Argentina?
Rio Negro province. The rocks there are called the Anacleto Formation.
And that dates to...
Late Cretaceous, probably early Campanian age.
Right. So what exactly did they find? What makes up this A. wichmannianus?
It's a collection. Catalog number MACN 6904. And it includes skull fragments, there's a brain case, part of a lower jaw, a neck vertebra, a tail vertebra, bits of ribs.
And limb bones.
Yeah, several limb bones too, including a femur that's about 1.39 meters long.
Okay. But you said a collection.
Exactly. Critically, von Huene didn't pick a single holotype specimen. It's an assemblage of syntypes.
Syntype. So like multiple defining pieces, not just one.
Kind of, yeah. It makes things complicated because you can't be 100% sure they all came from one individual animal.
The paleontological mixed bag then. So based on this mix, how big are we talking for wichmannianus?
Roughly.
The estimates based on that material hover around 17 meters total length, so maybe 56 feet. Really big. Decent size. But wasn't there something about even bigger leg bones found around there? Bit of a controversy.
Yeah. Yes, you're thinking of the other femur von Huene included, a much bigger one.
How big?
1.85 meters long. Massive. He also referred a tibia along with it.
Whoa! So nearly 2 meters just for the thigh bone.
Exactly. But, and this is a big but, later paleontologists have really questioned if those huge bones actually belong with the rest of the wichmannianus material.
So they might be from a different dinosaur entirely.
Quite possibly. It's like finding, I don't know, a bicycle wheel next to motorcycle parts. Are they from the same thing? Maybe, maybe not. Some studies suggested that big femur might be something like Carloversaurus, or maybe just some indeterminate titanosaur we can't quite place.
And that giant femur, that was used for some size estimates too, wasn't it?
It was. That's where the estimate of about 34 metric tons for A, which wichmannianus came from.
So if that bone doesn't belong, that number might be way off for wichmannianus itself.
Precisely. It throws a real wrench into understanding the size of the type species.
Okay, let's shift to the skull bits. That jaw sounds pretty weird squared off. L-shaped.
Yeah, it's very distinctive. The lower jaw, the mandible, has this sort of blunt, almost right-angle front. And the teeth are described as small, pencil-like, and they're only right at the very front of that lower jaw.
What would it eat with a jaw like that?
That's the million-dollar question. The unique shape led to ideas about specialized feeding, maybe cropping low plants, maybe skimming stuff off water.
Interesting. But I remember hearing a debate. Maybe the jaw wasn't even from a titanosaur. Could it be something else?
That was a major point of discussion for a while because, it does look a bit like the jaw of Nigersaurus.
Nigersaurus. That's a rebbachisaur, right? Different branch of sauropods.
Exactly. Nigersaurus had that wide, vacuum cleaner mouth packed with teeth, up to 7 replacement teeth behind each active one, I think.
Wow.
So the similarity made people wonder if the Antarctosaurus jaw actually belonged to a rebbachisaur found in the same area.
Man.
But then, in 2004, they described Bonitosaura,
Huh.
And Dinosaur was definitely a titanosaur found with its skeleton, and it had a very similar squared-off jaw.
Okay, so that showed Titanosaurs could have jaws like that.
Precisely. It was a strong counter-argument. And then later finds like Bristolodonton in 2013 and Bolosaurus more recently in 2019.
Let me guess, similar jaws.
You got it. Both described as Titanosaurus, closely related to Antarctosaurus, and both with those squared-off mandibles.
So the jaw probably is Titanosaurian, just an unusual type.
It seems like the most likely explanation now, yeah. Maybe that shape evolved more than once.
What about the rest of the skull, the brain case? Any clearer?
Still a bit murky, honestly. The back of the skull, the brain case, generally looks Titaniconian. But again, the question is, does it belong to the same animal as the jaw or the limbs?
Right.
Jeffrey Wilson, back in 2005, even suggested the brain case might belong to a Nemegdosaurid. That's another group of titanosaurs, often with more complete skulls found.
So potentially bits from different types of titanosaurs all mixed together. A real Frankenstein's monster scenario.
It's a possibility you can't rule out easily. Though a CT scan study in 2012 by Ariana Paulina Carbajal helped a bit.
What did the scans show?
They looked inside the brain case at the shape of the brain cavity and inner ear. They found features like short, sideways pointing olfactory tracts, the smell bits that are shared with other known titanosaurs.
So leaning back towards Titanosaur, for the brain case at least.
Yeah, it strengthens that argument, but still doesn't confirm it's the same titanosaur as the jaw or limbs.
Did anyone look at the skull size compared to the body? Does that match up?
Yes, Shamie Powell did that comparison. He looked at the skull width versus the limb bone lengths, and he found the skull seemed proportionally pretty small compared to the limbs, especially when you compare it to something like Saltosaurus.
Another Titanosaur.
Right. So Powell and others took that as maybe another hint that the skull and limbs aren't from the same individual, or maybe even the same species.
But there was a catch.
Yeah, Powell himself noted that Saltosaurus is a pretty stocky, robust titanosaur, so maybe it just had a relatively bigger head for its body size compared to a potentially more gracile Antarctosaurus. Not conclusive.
Okay, ankle bones too. Any issues there?
Yep. Von Huene described an astragalus and a calcaneum, two key ankle bones.
Standard stuff.
Well, Powell later suggested the bone of Von Huene, called the calcaneum, might actually be an astragalus from a smaller, younger animal.
Oh, okay. And the main astragalus they have seems maybe a bit too small to go with the big tibia found. Like the ankle doesn't quite match the leg size. Man, it really is like a jigsaw puzzle with pieces missing and maybe pieces from other puzzles thrown in.
That sums it up pretty well.
Yeah.
And there's even a tail vertebra found near the skull that adds another wrinkle.
Don't tell me. It might not belong either.
Well, it's a first caudal vertebra right behind the hips. Von Huene himself wondered if it might possibly belong to Laplatosaurus, another titanosaur known from Argentina. It has a feature being biconvex, curved outwards on both ends, seen in some titanosaurs, but yeah, its association is uncertain.
So many question marks around Leishmanianus. It sounds like the biggest problem is just we don't know how these bones relate to each other.
That's a huge part of it. There are basically no connecting vertebrae between the skull stuff and the limb stuff, apart from that one neck bone and the questionable tailbone.
And the field notes from 1912 probably weren't super detailed about exactly where each bone was.
Exactly. That detailed mapping, that taphonomy, just wasn't standard practice then. It makes it incredibly hard to be sure these weren't just washed together after the animals died.
But you mentioned Powell argued Von Huene might have had good reason.
Yeah, Powell suggested Von Huene likely talked directly with Wichmann and the Discovery team, maybe saw photos or notes we don't have anymore, giving him more confidence in grouping them together than we might have just from the published record. But it's still inference.
Okay, wow. So Leishmanianus is complicated. Let's move on to the really big one, potentially big one. Antarctosaurus. Giganteous.
The name says it all, right?
Pretty much. Von Huene named it in the same 1929 paper, but he put CF before it, meaning compare with. He was tentative, mostly because it seemed so enormous.
Where did these giant bones come from? Same place as Leishmanianus?
No, different spot. Platier Formation, also in Argentina, but New Queen Province this time.
And geologically, same age.
Slightly older, it seems. Coniation to Santonian stages of the Late Cretaceous. So, different place, slightly different time than Leishmanianus. Different time, different place. What bones do we actually have for Giganteus? Is it more complete?
Unfortunately, no. It's very fragmentary, too. The main specimen, MLP 26316, has two femora left and right thigh bones.
The famous ones?
Yep, the huge ones. Also partial pubic bones from the hip, the bottom end of a tibia, bits of ribs and tail vertebrae, and like 6 other big bone chunks they couldn't identify for sure.
And those femora. How big are we talking again?
Astounding. 2.35 meters long.
Wowzers. That's like taller than most doorways.
Easily. They are among the largest dinosaur bones ever found, period.
But you mentioned something about them earlier. They were slender.
Relatively speaking, yes. For their immense length, they aren't as proportionally thick or robust as, say, the femora of Argentinosaurus or Patagotitan. So, incredibly long, but maybe slightly more gracile giant, if that's not a contradiction in terms.
A slender giant.
Okay.
But with remains this fragmentary, what's its official status? Is Giganteus considered a valid species?
That's highly debated. Because it's known from so little, many researchers consider it a nomen dubium.
A dubious name.
Meaning the fossils are just too incomplete to be sure it's a distinct species or to reliably compare it to other finds. You can't define it properly.
So it's stuck in paleontological limbo.
Pretty much, although some think it probably is a valid species, but maybe it needs its own new genus name, separate from Antarctosaurus.
Wasn't there some idea about it being a growth stage of Wichmanianus?
Ah, yeah, Lee Van Valen suggested that back in '69. He thought maybe Wichmanianus was young and Giganteus was the adult of the same species. He even preferred the name Giganteus.
That doesn't really work, does it?
Not really. First, naming rules mean Wichmanianus has priority because it appeared slightly earlier in Van Huen's paper.
Okay.
And second, as we said, they're from different formations, different times. Makes the growth stage idea pretty unlikely.
Right, so Giganteus is huge, maybe valid, maybe not, probably not Antarctosaurus. This must be where those wild size estimates come in.
Absolutely. Those giant femora are the basis for all the speculation about its size, and the estimates have been, well, all over the map.
Give us the range. How big could this thing have been?
Okay, back in the 50s, Risconi suggested maybe 30 meters long.
98 feet. Okay.
Van Valen in '69 compared it to Geophytotan and guessed around 80 metric tons.
80 tons.
Greg Paul in the '90s went even bigger, maybe 80 to 100 tons and 30 to 35 meters long. That's pushing 115 feet.
Just mind-boggling numbers.
Totally. More recent estimates have varied too. Mazzetta and colleagues in 2004 estimated about 69 tons.
Still huge.
Carpenter in 2006 used Saltosaurus proportions and got a shorter length, around 23 meters or 75 feet. Thomas Holtz estimated 33 meters, maybe 33 to 65 tons, like 9 elephants worth.
Quite a spread there.
It is. A 2016 study using bone circumference estimated around 39.5 tons. Greg Paul revised his own estimate down in 2019 to maybe 45, 55 tons.
Okay.
And Molina Perez and Larmendi in 2020 suggested about 30.5 meters and 45 tons.
So the only consensus is it was probably very, very big, but we don't know how big because the fossils are so incomplete.
That's the bottom line. Huge potential, massive uncertainty.
Okay. So we've covered the 2 main Von Wayne species. But other dinosaurs got lumped into Antarctosaurus later, right? What happened to them?
Yeah, 3 others were named under Antarctosaurs over the years. Their stories are pretty typical of how classifications change as we learn more.
Let's take them one by one first.
Antarctosaurus septentrionalis. This one's interesting because it was found way over in India, in the Lametta Formation.
India, wow. Von Huene described this one too.
He did, with Matley in 1933. And actually, these Indian fossils were better preserved in some ways than the South American ones, providing good anatomical detail.
But India seems unlikely to be the same genus as an Argentinian dinosaur.
Exactly. As paleontologists studied Titanosaurs more, it became clear this Indian form was distinct. So in 1994, it was given its own genus name, Dinosaurs.
So septentrionalis graduated to become Dinosaurus. Makes sense. Who's next?
Next up is Antarctosaurus jacksarticus. This one's based on just a single femur from Kazakhstan.
Kazakhstan. Even further afield.
Yep. Named by Ryabinin in 1938. It was actually the first sauropod named from Kazakhstan.
Just one bone, though.
Just one femur. And they don't even know precisely where it was found, though maybe the Siksik Formation, Santonian age.
What's its status now? Still Antarctosaurus.
Oh, definitely not. Its status is super shaky. Some call it Titanosauridae, inserte studies, basically uncertain placement within Titanosaurs.
Okay.
Others say it's a nomen dubium because the single bone isn't diagnostic enough. Some even suggested nomen nudum, meaning it wasn't properly described initially.
So barely even a species, let alone Antarctosaurus.
Pretty much. There was a note it resembled Dinosaurus a bit, and maybe it belongs in the group Lithostrotia, but mostly it's just an enigma, a fossil ghost.
I've got it. And the last one?
Antarctosaurus brasiliensis, found in Brazil in the Adamantina Formation. described in 1971 by Arid and Vizotto.
Okay, back to South America at least. What do they find?
Not much. 2 bits of limb bones and part of a vertebra. The femur fragment suggests an original length of maybe just under a meter. The vertebra centrum was about 17 centimeters long.
And its fate. Let me guess.
Nomen dubium, or indeterminate titanosaur. Too fragmentary to say much more.
So it really seems like Antarctosaurus started as this potentially huge genus, but over time, most of the species assigned to it have been questioned or moved elsewhere.
That's a perfect summary. Trying to define Antarctosaurus is incredibly challenging because the type species, Wichmannianus, is based on that messy collection of bones with questionable links.
And everything else is either dubious or now its own genus, like Dinosaurus.
Exactly. It leaves the genus itself in a very confused state taxonomically.
But despite all the confusion about the specific bones and species, we're pretty sure it was a titanosaurian sauropod.
Yes. The available evidence, especially from the Wichmannianus brain case and general limb bone features, strongly points towards titanosaur affinities.
So what does that tell us generally? What were titanosaurs like?
Well, your typical titanosaur was a large, four-legged herbivore, long neck, long tail, relatively small head compared to that massive body. Many also had bony armor plates, osteoderms, though we don't have direct evidence of those for Antarctosaurus itself.
And when scientists try to place Antarctosaurus, whatever bits they're using in the titanosaur family tree, where does it land?
It hasn't been included in tons of analyses because of the uncertainty, but a 2019 study by Philip Mannion and colleagues did put it in.
And the result?
Their analysis consistently placed it close to Vihini, and Dinosaurs, remember, Dinosaurs used to be A. septentrionalis. This little group often showed up near the base of Loncosauria.
Loncosauria. That includes some real giants, doesn't it?
It does, like Pseudoloncosaurus and Patagotitan. So it suggests Antarctosaurus might be related to the early evolution of some of the largest land animals ever. It's generally placed within the broader group Lithostrotia as well.
Okay, so wrapping up this deep dive, it feels like the story of Antarctosaurus is mostly about uncertainty and detective work.
Absolutely. The key challenges are still that problematic mix of bones for A. wichmannianus, the very scrappy nature of Giganteus and the others, and how hard that makes it to classify them or even estimate their size reliably.
Yeah, for me, the real aha is that contrast. You have the name southern lizard, suggesting maybe something medium-sized, but then these hints of absolute gigantism with A. giganteus.
Right.
And it just shows how paleontologists have to piece things together from scattered clues. That jaw debate alone shows how much you can learn or argue about from just one bone. It's fascinating.
It really is, and it leaves you wondering, doesn't it? With all these debates and the patchy fossil record, how much of our picture of these extinct giants is solid fact and how much is, careful guesswork?
Points get inference, yeah.
What discovery might come along next week or next year that just completely changes how we see Antarctosaurus? It reminds you that paleontology is a constantly evolving story.